Hello everyone, welcome to a new video and Harsh Verma this side and welcome to our topic for the day, high availability from the same book, Network Warrior. For those who don't know or not following the series, this is the book Network Warrior, everything you need to know that was not on CCNA examination. This book is by Gary Dornow. So basically this book outlines the topic and focuses on the practical application of the information and also talks about the things that we missed during our CCNA preparation. So we are not going through or reading through the book by cover to cover, but only covering the topics that I feel need to share with you all in order to help your personal or career or basically your networking journey. Okay, so let's SSH into my this smartphone because I use this smartphone to take notes and here it is. Okay. So today the topic for the day is high availability, and in order to facilitate high availability, we use two or three protocols, which is HSRP, VRRP, and GLPP. We will get to have a look what are they and what things you need to keep in mind in order to implement them. So starting with HSRP, which stands for Hot Standby Router Protocol, it is a Cisco proprietary protocol, and HSRP works by making HSRP group with active and standby as its member and router as its member. So what does it mean? That consider a scenario in which we want to have two routers act as an uplink. Uplink means the connectivity to the wide area network. So in case of one wired connectivity or one wide area network connectivity goes down, or if one router got some fault and it gets powered off, then what we want is automatically load shift the entire traffic to that second router. So it uses its second router as an exit gate. So one router will become active in this scenario while the other router will actually not help to forward the traffic but always be available as an standby state. So if there are more than two routers, the one router will become active while the other becomes standby, while the remaining routers are not active or passive. So this is the scenario when we include multiple routers in HSRP group. There may be an active, a standby, and while the other router may not be assigned a state, it will be also be present as its simple plain member. Now, only the active and standby router shares the periodic update because the HSRP uses the keep alive message to keep check on each other whether the router is available as per backup or if the standby router failed. So this has to be kept in check, and this the active and standby one uses the periodic updates. Okay, now the priority ranges between 0 to 255 and 100 become the default HSRP priority. Okay, and here the higher priority is preferred. For example, if we configure two routers and both have the 100 priority, then some router has to be become active. And in order to make a router definitely active, we can raise its priority from 100 to maybe 101 or 110. A maximum it could be 255. And yes, in order to share the updates, the HSRP protocol uses the IP address which is 224.0.0.2 and UDP port 1985 with a time to live of 1. So time to live of 1 means the router should be present and a single hop. So this router should be accessible by 1 because these messages cannot be broadcasted over some very far link. Okay, now we can also implement the preemption. The preemption is a methodology in which suppose we have a two router, router A and router B, and we want that router way always becomes the primary router. After a failure in router 1, if we want to or if we fixes the router A, then we want router A to be take place instead of router B, which after the failure will become the primary. So in order to switch back the primary to router A without causing any disruption, we use the preemption command. Okay. So to enable preemption, we use the command standby preempt. It enables the active router with the highest priority to immediately become the active router as soon as it is it back in the network. And HSRP interface tracking allows router to change its priority on the basis of a status of another interface. So basically, it provides the tracking facility. For example, if we can check whether if this particular interface goes in down state or have some error, we can just directly shift the to that another router. And in order to do that, we use the command standby track gig 0 over 0 and 10 will track the status of interface. In case of a failure, it decrement the priority by 10 if the interface goes down. So basically, the tracking helps us to increment or decrement the uh, router's priority by 10. We can use figuratively any value and it will decrease that value from the HSRP priority, and lower the priority, the less preferred that router will become. For example, if we use 4 links for the uplink, so if we assign every 10 values to each of the interface, as soon the first interface down, the priority automatically drops by 10 if we are using the 10 as a value. Now, HSRP link tracking does not work well with the Sonnet links because the optical circuit is converted into Ethernet. Unplugging the link on one side of the circuit may not cause the far link to go down. Basically, Sonnet is a different type of networking context. So, where we are transferring the link, because there is a conversion in medium, the mediums get converted whether we are receiving any packets or not. So HSRP basically tracks the layer 1 availability. So in case of Sonnet, the layer 1 availability will always be there, because Sonnet is a kind of black box networking in which the ISP takes care whether the data being transferred from one place to another. So we are connected to ISP and this shows the link up whether we are receiving any form of information or not. So that's an exceptional case, but HSRP link tracking does work well with the normal Ethernet networks, in which if an Ethernet interface goes down state, then it will decrement the priority as expected. And now, as we study and as we already know about the Nexus OS, the HSRP is a feature and need to be enabled, because in Cat OS or iOS, these features are already been enabled, but NextOS requires it to be enabled as a feature HSRP command. And yes, we also have to keep in mind that HSRP behaves differently on NextOS, specifically when using VPC. VPC stands for Virtual Port Channel. And yes, from studying these type of daily lessons, I've been studying about the VPC a lot in the book, because in future chapters it is explained in more detail. So that time will also come soon. So what different behavior does HSRP show on NXOS? So packet received on the routed port L3 port destined for an HSRP virtual IP will be terminated on that router whether the router is active or not. So as we know, we have already studied that HSRP informations have a TTL of 1. Despite that, if it's a Nexus router with a routed port, the packet will not be forwarded any further, and the packet received on the switch port, which is an L2 port, will be forwarded to an active router. Okay, finally, this helps to reduce the traffic on the inter-router link, means the connectivity between two routers. And finally, the VPC between the two Nexus devices, virtual port channel between two Nexus devices, will forward the traffic through both active and standby router. So let me clear the virtual port channel first. The virtual port channel is a Cisco proprietary MC lag like connectivity in which two separate chassis switch act as a single management plane. Basically, they have different control planes, but and management plane, but they have similar or same joint data plane. So both switch can be act as to build ether channel and connect to multiple devices. Finally, there's a lot to talk about GLPB, and I think I will discuss the GLPB in the forthcoming video, which I will be making soon, just right after this video. So this is for this video. Please keep in mind to watch the next video in order to complete this high availability series.